Again, gang, we're back with GEOG61 and our introduction to incident mapping, and this will be video 3, creating a search and rescue incident. And I think one of the first things we'll do here, why don't we change the base map? This doesn't show trails very well, so I'm going to choose the USGS national map, which is closer to the actual paper USGS map, which most of our SAR teams are familiar with and all carry quads of the area. And it also does a better job of showing vegetation and terrain. So you'll notice down here is green, which indicates vegetation, and up here is just the bare contour lines, which shows no vegetation for alpine areas. And it also shows the trails much more clearly here, so that'll help us quite a bit in planning. And one thing I haven't done is added any data. So for instance, Sequoia King and the Forest Service, you can get a hold of trail layers as well as ranger stations and other relevant feature classes, but we're just trying to do this reasonably quickly, so I won't include those. Now, as I've said before, a search, or a missing person anyway, an overdue person, it's kind of a random event in the sense that you don't know where that person is. I mean, the person has done something unexpected. He or she left point A and is expected to arrive at point B and hasn't shown up. And so you have to take what you do know, and this is usually the result of investigation, and you have two levels of investigation. You have one that's actually law enforcement investigation. For instance, maybe the person just took off and isn't even in the search area, and then you have the searchers doing actual investigation looking for clues. So for instance, in this case, we know the person's car was at South Lake, and we know that a spot device that the person was carrying was activated over in the Palisade Basin here, Barrett Lakes, and gave an exact point and a time when he was there. So a very good chance that the person at least got to there, and after that you send in searchers to see if you can pick up other clues to narrow it down. There's a phrase, the map is not the territory, which is pretty much true, but as the GIS specialist, it's our job as much as possible to represent the terrain by showing it on a map and to represent what's going on. So defining the search area, as I've said before, imposing our own order so that we can search it in a logical way. One of the problems is if you've got experience in wilderness, in this case it's a wilderness search, it's hard to imagine what a person might have done because, you know, as I said, they made some sort of mistake, and even though you know, there's a lot of search literature out there that says, you know, the X% go uphill, X% go downhill, and so on and so forth. People just do totally unexpected things, and I've not found it useful to use statistics to predict where someone's going to be. That's open to argument, but that's been my experience anyway. And in this case, there were two agencies working on it. The Inyo National Forest is here in the north, and here's the boundary line for Sequoia Kings National Park. And so in most of the U.S., jurisdiction for a search is carried out by a sheriff, the county sheriff, except for national parks, where the National Park Service has exclusive jurisdiction. So this is two agencies working together, and fortunately they do this a lot, and so they're pretty good at it. So again, we're going to stick with the park side of this, and let's zoom in a little bit here. And a couple of housekeeping things we're going to do first. One thing you'll want to do, not only in SAR or FIRE, but pretty much all your projects is to create what are called group layers, and that helps you put your data into more relevant folders. So otherwise you get a big long string of data and feature classes over here in the table of contents. But if you create little folders, you can keep it cleaner over here and better organize your data. So to do that, you right click and put new group layer, and then you click inside of it and we'll give it a name. We'll just call this SAR data. Not a great heading, but let's go with it for the moment. And into that, let's put our clues. So highlight that until it bring it up, and our points, even our scratch data, and our perimeter, and segments. And so now we have data and USGS topo. And under data, we might later add another folder for GPS and separate that out. And you have a controlling box here. So if you unclick the SAR data, then everything below it is no longer visible. So you can, so let's say you have air operations and you have all of the tracks for air ops, and that's in a separate folder, and you don't want it obscuring your ground operation. So you can click that on and off, make the map more easily understood. And okay, just a couple of quick changes here. Initially I said that we didn't have to add another field to clue, but in fact let's do just that. So I right clicked and I'm going to bring up the attribute field to clues, and I already did it here. Go here to add and add field, and so it brings up the fields box, and I added a field called description, which is text. Because we've got the label and we want a field of what the item that was found is. And remember, label is connected to our clues domain on the relevance of the clue. And so I'm just adding a description here, and it's now added a field which we don't want. So let's, I'll delete that. With luck, you guys didn't create that. And let's save. And we're going to do the same thing to segments. So right click and bring up the attribute table, and we're going to add a field called status, and so that's going to refer to whether it's searched or not searched. So we'll just call this field status, and it's going to be another text field. Save that. Okay, let's just get rid of all of those and get these out of the way. So next, let's work on our symbology here for each the points and the clues, which have the domains linked to them. So that brings us to the symbology pane, and as we did with fire lines, we're going to have the unique values here, and it's going to go by the type field, which you remember is associated with the domain. And now let's add the all values, which is last known point and PLS, and so that gives each a separate symbol. So let's click on Format Symbol and go to the gallery. And down here is last known point, so let's go ahead and assign that to it. And now we'll do the same thing for PLS, point last seen. So for that we scroll down here, and there's point last seen there. Now, another thing about symbology is that it allows you to look at a map without constantly referencing the legend when we print it, so that people who are used to SAR or FIRE can just look at the map and know what those symbols are, because they're used to working with that. And so then, of course, there's an art to creating symbols that you can kind of intuitively understand what it means. And so when we were designing our SAR mapping apps and workflows, a lot of time was spent on getting symbols that pretty well represented uh, what they were on the map, and also incorporating symbols that were already widely used in, say, fire or other disaster type operations. Now, let's do the same thing with clues. And so notice so now we'll do the same thing. We will choose unique values, and it will be off the label field, and we'll add those values. And so it's not relevant, relevant, and unknown. So let's get a not relevant symbol here, clue not relevant, and go back. And let's get a relevant clue. Clue relevant, and back, and unknown. And back. And obviously they now appear in our contents here. So let's save that. And so that's an advantage of putting in domains ahead of time, because that allows us to have unique values that we can use for the symbols. So for instance, in these other feature classes, we don't yet have values, but once you put in values for, let's say, segments or something like that, then you can create unique values once you have them. But with a domain, they're already defined, and you can then create fields even without any actual data in those fields yet. And one other note here is that we're kind of plodding along here. Obviously, we're learning about it. But once you have everything set up, it can go, and it should go, pretty quickly. I mean, that's the whole point, is you predefine your template and your symbols and everything like that. And if you're into search and rescue, you can set all this up ahead of time and then save the entire project without any actual data in it. So you've got your schema ready to go. And in mapping, it's the maps that quite often are the last things done on an incident. So you have your briefing in the afternoon or even 6 or 7 o'clock, and then the GIS person does the maps for the next morning, both IAP and briefing maps. And so in the old days, and actually it's still true, you're there till at least midnight. But once our crew designed the MapSAR and the automated process to do this, we actually would go pretty quickly, and an experienced mapper could get team maps out in 30 minutes, for 10 or 15 teams, for the next morning, and that was pretty darn amazing. So it really speeds things up. Okay, so let's finally start drawing our search here. And one of the first things you do, and it's often not done on searches, but it is pretty important, is you want to draw a search boundary. That is the area in which you're going to have the initial search, and that can be based on a couple of things. Terrain. So for instance, you might have a ridge or something, or a river that you don't think the person is going to cross. And the other consideration is time, since the person was last seen or last known to be somewhere. And so how much time did that person have to go a certain distance, and that distance becomes the edge of your boundary. And ideally, and again, this doesn't always happen, you want to put trail guards out at the extent of that distance, and the person just sits there and interviews people going by and makes sure that your missing overdue person doesn't go by, which also happens because sometimes they don't know they're overdue, and so there they are. But interviewing the hikers going along the trail is incredibly important, because then they either did or didn't see someone. You can jog their memory, and you at least have their route. And as I've said before, you can't eliminate terrain necessarily, from a search, but you can make it a lower priority if enough people didn't see the person. So we're pretty much going to just do a terrain-based boundary, and it won't be necessarily exact to the search, but just so you see how to draw it. So let's choose our SAR perimeter here and go into editing mode. And we're going to start an edit session. We're just going to create a polygon here and highlight SAR perimeter. We're just going to draw this in quickly here. So I'm going to choose the freehand tool, and we're going to do it essentially by terrain. So because this is just for Sequoia Kings, I'm going right along the boundary here. And we're going to include both Barrett Lakes and Doozy Basin. Come down this ridge here. And because of that drainage, I'm even going to then bring it back up to this ridge here. So that's a huge search area, and it was actually our primary search area. Now let's change the polygon. And in this case, we're just going to make it a black outline and clear, so obviously we can see the terrain underneath. And let's unselect it, we'll clear it. So there's our search boundary for the initial part of the search. And you may expand that as you search an area and you're not finding anything. And you might need to expand that depending on other clues you may or may not pick up or other theories you have on where the person might be. I'll just mention a little side story here on people doing unexpected things. A few years ago, we had a search down in the Mount Whitney area, and some guys came in to the south of Mount Whitney over a cross-country route, and their intent was just to circle around this little ridge and go up and out over Whitney. Well, it snowed. Again, it started out as 4 people, and one guy bailed just coming up the trail, and then the second person the next morning, just before they really started out on their trip, it was snowing lightly, and the person said, this isn't a great idea. And so the other 2 said, let's go. And so they did. Well, it snowed heavier, of course, and they thrashed through maybe a foot of snow. And instead of turning and going up Whitney, which is what we as the searchers expected them to do, they just kept going north. They went off their own map, so they didn't really know where they were. They didn't have any experience. They were just heading north on the John Muir Trail. Now, about 4 days later, some other hikers, we'd been searching for 4 or 5 days and hadn't found any trace of them. And they had gone 2 or 3 days north of our search area. And it just happened they ran into some other hikers, and we had flyers everywhere, and the other hikers said, you guys are overdue. So they helped them out back down to the trailhead. But they had gone by 3 different side trails that would have taken them out of the mountains and down to a trail. So that's what I mean. People do unexpected things, and it's just really hard to imagine what those things are. And so you just have to, I don't know, be prepared for weird stuff. Okay, we're still in editing mode, so now we're going to create, let's lock this into place. We're going to create the last known point based on the person's spot signal. So in this case, you come out and you can see it's already going to draw. So we can either put it in by hand, but I'll just show you once again how to set it by absolute XY. And if you remember, in your written material, I had the XY location of the spot signal. And so I'm just going to copy and paste that. I have this on my other monitor. So let's paste in the longitude, and that's in degrees, decimal degrees. So let's paste that in. And now I'm going to do latitude. hit enter, it shows up at that point. Let's just zoom in. And now I'm holding down the C key to center it a little better. And now let's bring up the attribute table. I can fill it in. So we have last known point. The label is LKP, and the date, well, we'll just make it yesterday for our purposes. And I'm sorry, the type, the label is spot signal. So now we have a point sort of from where to start, and we have an area that we're going to work in. And the way searches are run is you draw in segments, polygons, that define the area that you assign teams to. And theoretically, the segments are an area that a team of 2 or 4 can cover in a day. That's not always the case. And there's assorted arguments over whether it should include really high angle terrain. And I tend to just draw in the full segment, even if it's terrain no one's going to search. But there's arguments back and forth either way. And in any event, we're just moving right along here. So we're going to draw in just 3 or 4 segments and use that for our map, even though in practice you might actually do more. And you add more as the search continues and you don't find someone. So let's save these edits because they're good. Save all edits. Yep. And let's clear the last known point. And incidentally, if someone had been coming through and actually seen him there, that would be a point last seen. So now let's do our segments. And we're just going to draw in big ones here. And let's create a segment and highlight segments. Oops. And here's all the tools we can use. And so initially, you can do the create polygon where each click establishes a direction to change from, or we can do the freehand tool again. And since I'm moving quickly here, I'll use the freehand tool, but whatever you guys are comfortable with. So let's draw one segment into just Doozy Basin here. So let's start along this ridge here and go up, follow the boundary along. And I'm just drawing pretty darn loosely in here, obviously. And come down the ridge, and then I'm going to come across and include these lakes here, and just because of elevation, and then bring it around here and click to end. And holding down the C key here just to maneuver, and let's come in a little closer here. We'll now do the same thing with Barrett Lakes, and we'll draw another polygon there. And one pretty darn cool tool here is the Autocomplete Polygon tool. And what that does is there's an autocomplete for both the polygon drawn point by point and the freehand tool. And for that, you start inside and then draw around your area and complete it inside the other polygon. And what it does is it gives a solid a common line that they join on. And otherwise you've got to trace along here and then around and around. And it doesn't necessarily create a well-matched polygon. So anyway, click inside, and we've highlighted the freehand autocomplete here. So we click inside and draw around. And I'm going to come down this ridge here. And I'm staying in the upper part of the basin, and then click inside. And notice how it gives this clean join of the 2 polygons. Okay, C key down and move the map. Okay, now we're going to show another kind of cool technique. And even though I'm not drawing this exactly as a SAR would be drawn and assigned, I'm going to the scratch line tool here, the scratch line that I had you guys create. And let's once again do the freehand tool. The freehand tool isn't very exact unless you can trace it along, snap it to another object, but I'm just going for speed here. So I'm going to follow this trail down, and I'm not going to do the switchbacks. We're just going to follow it generally, and I'll show you why we don't need to do the switchbacks. So but just generally go on down, and let's go down to the Muir Trail here. Now, obviously, that line is a different feature class. It was drawn just to do scratch lines, and that's not a bad idea on fires or searches. You might want a polygon line and point that you can just draw stuff in that might not be an official part of the fire, but you might just want to sketch stuff in to see how it works. And the same is true on any other project you work on. It just gives you something to just try different drafts of a feature class you might eventually add real data to. So now that's highlighted, so it's selected, so we're going to modify it. And so the modify tool set comes on, and that's locked into place. And now we're going to add a buffer, which means that we're going to buffer that line out a distance that we can assign. And so we also choose, and this is the cool part, we choose a template. And so we're going to assign the buffer that we create to the segments. And so that means we're actually going to create a segment polygon. And I'm going to put it at about 100 feet here. You can fool around with it. Well, let's put it at 125. There's a couple of different ideas with this. We're doing a trail, and so you have a team going down the trail, and the idea is you want to represent the area that they can see from the trail. So say 50 feet to either side of the trail, although that's pretty general depending on vegetation and so on, tree density, etc. But you also want it big enough such that it's visible as a search segment. So in any event, 125, and you can choose the side of the line that's buffered. So I'm choosing both sides, and then just the end shape square around, but we don't really care about that. So let's go to buffer, and it immediately buffers it out into another search segment. So that's pretty cool, and that's big enough. It's clearly defined as a search segment. So we'll just use that. And let's just draw in one more segment, and then we can call it quits here. Last, we're going to auto-complete just a third polygon here. And so once again, back to segments, and I'm gonna choose the autocomplete freehand tool here and go inside. I'm coming down just along the ridge here, down to the trail, follow the trail up, and then click inside. And notice how that completed it and created a common boundary. Okay, so we've created 4 segments. That's pretty good. And I'm going to clear our selection there, and holding down the C key here, let's come in a little closer here. Let's save our edits, and for the moment take us out of editing mode and center that again. Now let's assign a symbol to the segments here. Now notice you have a whole bunch of different polygon assignment types here. You have assignment completed, assignment assigned, abandoned, in progress, etc., etc. But you can get too complicated and carried away. I think for our purposes here, we're going to make them all assigned because we're going to assign teams to each of those. So that gives a pretty solid color here, and obviously we want this to be transparent so we can see the terrain underneath. So let's go over to appearance and make sure you have SAR segments highlighted here, and we're going to add transparency to it. So let's bring the transparency up to well, pretty high there. Okay, I've got it at, I don't know, 70%, say. Um, anyway, again, the point is to see the terrain underneath, and you still have the boundary here that shows up pretty clearly between the segments. Now we're going to label the segments and create labels, and then I think we'll call it for this video. So that means back to editing and bring up the attribute table. Let's resize it. And now start an edit session so we can add some segment numbers here. Segments can be done by either numbers or letters. I'm going to use numbers here, so just 1, 2, 3, and 4. And notice over here in status, we're going to skip this, but in status you could put assigned, not assigned, searched, and then we could have made unique symbols for those and symbolized accordingly, but we'll skip that because once again we're just doing a quick demo here and trying to get you guys used to the new tools. So let's save those. And let's now label them. And so let's get out of edit mode. We don't need that. And move over to labeling. So you can do labels. If you already have it set up, you can just right click and you can go activate labels here, or you can just activate it here. Now notice that the field that it's going to go on is now at shape length, but we don't want that. So we want the segment, and so it put in numbers, but again in our case it would be good if it said segment 4, etc. And we could have actually just created a label with segment 1, segment 2, etc. But I want you guys to practice with actually creating an arcade expression or whatever language you want to use, but we'll use arcade. And so that's clicking on the expression icon here, and that brings up the segments and the label stuff. And right now it's on segment, which is correct. And so right at the beginning here, we're going to put in quotes, segment, and a space, an end quote, and then a plus sign. And let's check it to see if it's right. And it is, expression is valid. So let's apply it. And so that just puts in segment 4. And we may want to fool around with the size and so on, but for the moment let's keep it at that. And so let's do the same with SAR points label, and we want it to show the label. So spot signal shows the description, and theoretically the type of symbol there indicates what it is, last known point, but we could put in LKP, so we can actually put in both the spot signal and the date and the LKP, but let's just put in the spot signal and the date. I'll show you how to do that. Again, it's already come up as the SAR points and how to write an expression. So we're going to put in a plus sign, a quote, and a couple of spaces, the end quote, another plus sign, and let's put in the date. So I double clicked and that puts in the date, and let's see what that gives us. The expression is valid, and so we apply. And it gives the full date and time. It's a little long, but again, let's go with it. So I think that's going to wrap it up for this video. And then in the next one, we will maybe locate these a little bit better and add another couple of clues. And then we'll add some GPS tracks from the search and print it to PDF, and that'll be it. So thanks, and see you in video 4.